Hi and welcome to another episode here from the Off-Grid Garage. In the ceiling tonight, in the ceiling of the garage, I'm working on this combiner box here for the west roof, and we have to replace the outgoing cable here. This is still 4mm cable, 2 times 4mm cables, and I want to use 16mm cables. I've already installed a new conduit here, this pipe, and this is where the cable will go through all the way down to our PowerWall. So let's have a look. Yeah, this is here negative and positive bus bar. Everything is isolated. I've checked the voltage as well. So there's basically only voltage on these contacts down here, but nothing up here anymore. And the cables are disconnected on the other side. Anyway, see this cable there? There, that's the one. So it's completely isolated, both sides. I remember this. We had to extend the cables here because they were just too short. What a fucking nightmare it was. Okay, so that's the old one out. And now we have to... that's a bit small here. We've got a big pipe here coming in, friends. I have to extend this hole here a bit so it fits the big pipe conduit, 32mm. So, well, the only way to do it is actually take off the whole switchboard here and then just twist it around a bit so I've got access with the step drill here and can make this bigger. I cannot see any other. I knew it would be messy. But that messy, I think I found a different way to do it. I've just taken off the DIN rail here and everything flips down now. And I may have enough access here for the drill bit now to get in from here. So let's give this a shot. It took me maybe longer to find the right camera position here to show you what's going on. Much bigger. Much bigger. Oh shit. I'm through. Yes. Hey, let's yes. It is in. Nah, it's not going through. This one band of corrugated conduit is already enough. Now it's through. To block the cable, I wanted to say. It is so hard sometimes. Yeah, bombenfest. Alright. So let's see. This is the pipe coming there. Okay, cut it off here. Yeah. It takes me longer to put the camera in position than the actual work, just for the shot, so you know. I hope you appreciate that. It's already there. You didn't say anything. All right. There has been close to 1 MWh of energy traveled through this cable. That is insane, right? Okay, so now we are taking the other end of this long cable and put some electrical tape on it to mark it, and then we pull this one through from the other end of the cable as well, and have one marked and the other one is not. Well, and then you ask, how do you identify the two cables then? At the other end here, you got the color coding on this end here. but how do you identify them over here? So this is our loop here. This is our loop of cables. There you can see it. And one of them has now the black color code at the other end. We don't know which one, right? Now we know exactly it's this one here. This is what I've pushed in. And then I put another color code on here somewhere. Guys, we are coming very close to a sunset here now. And this means sunset here in the off-grid garage for today. I will continue working on this mess tomorrow. I'll leave everything as it is, as always. Just close the garage doors and forget about it. Okay, this is everything we are doing today. I guess see you tomorrow then.
The next day.
Yeah, before we continue cabling our west roof solar here in the garage, these Novaris surge protectors have arrived today. And well, after a long search, I actually found the correct surge protectors for our solar system here, because we want them for DC, obviously, and my system voltage is only 150 volts. See, I've ordered these ones here before from AliExpress, and well, I've seen them in many videos online. Everyone is using these SPDs here, but they are actually not suitable. They have DC input voltage as well. You can see UC is 1000 volt DC. But this is exactly what they limit the voltage to. In case of a lightning strike somewhere in this area here, you could potentially have a higher voltage on your cables, on your solar panels. And this higher voltage would obviously go through all the cables into your equipment and destroy your charge controllers and your inverters, everything. So hence you should have these SPDs in your combiner box near to the panels, so they protect your cables from there. If there's anything happening on the solar roof or anything on the cables, these surge protectors will take care of it. Yeah, well, as I said, I have got 150 volt system voltage here for my solar panels, and these ones will limit the voltage to 1000 volts. So this does not help, right? If we would have 1000 volts on our solar charge controllers, they would not survive. So you should have the appropriate SPDs in your system. And these ones from Novaris here actually have a continuous voltage. And these ones here from Novaris have actually a continuous operation voltage of 155. Which is perfect. So we will never get more than 155 volt in our system. And this is well within the specs of the solar charge controllers. So how they work, basically, you connect your positive and your negative over here and a ground down here to your main system ground bar. And then these devices have these MOVs inside. This is a metal oxide varistor. And depending on the height of the voltage, it starts conducting. When you measure these SPDs now from here positive to negative or to ground, there is no throughput. They've got unlimited ohms. But if the input voltage reaches the critical voltage of these MOVs, they start conducting. And the higher the voltage gets, the more they are conducting. So, and because they are in parallel to your load, they basically shorten your positive and negative to the ground. And they can do this up to 40,000 amps. So these SPDs usually get tested with 8 or 20 microseconds of these currents. So I think they can withstand 40 kiloamps for 8 microseconds or 20 kiloamps for 20 microseconds. And here you can actually see how it looks like inside. They've got basically 3 different MOVs inside, and protect from positive to ground, negative to ground, or from positive to negative as well. So regardless what happens, you're always protected with these devices. And this one also has an alarm contact, so in case of a fault here and it turns on a light or a buzz or something, and you know you need to replace this device. And the same is basically for this one, positive, negative, and ground here. So they're all the same. And here you can actually take out these orange modules here and replace them. If they are faulty, they'll show a red symbol here in the window. And this one has LEDs, so this one shows you actually with LEDs what the status is. So far so good, right? Very straightforward. But here comes the thing. You should install these SPDs only with very short cables. Because as you can imagine, if you have 20,000 amps running through this device, every little millimeter of cable, every inch of cable will make a big difference in voltage drop. And if the cables are too long, these SPDs won't protect your equipment anymore. And the maximum cable length recommended for these devices is 50 centimeters. So a very short run from here, plus another short run from here, positive, negative, and a very short one from here to your ground bar, right? And then you calculate all these 3 cable lengths together, and they should not exceed 50 centimeters, even shorter, 30 centimeters sometimes regulations say. Well, this is all nice and good if you have this mounted somewhere in your distribution box, in your meter box, somewhere close to your earth bar, right? But how do you install them in a solar installation? Because we will have this surge protector up there in the combiner box, and there's no earth, no ground bar, no cable, nothing. To be honest, I cannot find an answer online, because I can of course connect positive and negative of the SPD to our positive negative orange cable coming down from there to our MPPT, and it would protect the cables and everything afterwards. But where do I connect the ground? There is no ground up there, right? So I would need to run a ground cable from here all the way through the conduit, all the way up here, and then all the way down here and connect it to our main ground bar. And obviously this is then longer than 50 centimeters or even 30 centimeters. So in case of a fault and we have 20 kiloamps running through these cables for very short, it's just a surge for a very short amount of time, it probably won't help, because the voltage drop on these cables is so long that the SPD cannot protect your cables anymore. And you will end up with a higher voltage on these cables. But how do you do that? I have seen combiner boxes online, they have these SPDs built in already. They have similar setup as the one I built here with fuses, and sometimes they have also circuit breakers inside, so you can connect all your single solar strings to it, and then connect your outgoing cable from the combiner box to your MPPT through the circuit breakers. And they come actually with a little ground bar inside where the SPD connects to. But how do you connect this ground bar? So you need to run a cable from your main earth bar up to the combiner box anyway. And then you have this long run again. So and rather these high surge currents go through your equipment, the earth cable actually should provide a lower resistance path to the ground bar. But if you have a huge voltage drop on these cables already, well, it's not easy for the current to decide where to go, right? So it may end up with going through your equipment rather than this earth cable, which is far too long then. Okay, as always, I'm very keen to read all your comments about this. How have you handled the SPDs in your installation? Okay, let's get back to work. And I also will run a 6 square millimeter cable, earth ground cable, through the conduit and leave it here in the box, just in case we connect this SPD here with a 7 or 8 meter long cable. I don't know yet. Waiting for your responses and tips. And here comes the cable with the marking. I tell you, all this cabling, just doing by yourself, takes 10 times longer. 10 times. It was so hard to get these cables through this straight pipe of conduit here. Unbelievable. Because this is like silicon cable, you know, this industrial, and it has such a high resistance when you push it through the conduit. It is just sticky as shit. I've used these plastic thingies here to pull in the cable and everything. That works kind of. But if you pull on the cable on this side here, you need someone else to push it in over there, because the edge is so sharp there, the cable won't slip in just by itself. It just would not do it. But now it's in. It's in. It took me like 2 hours or so to get this cable from there around the corner to there, and it's not even ready yet. There was a 2 hour, and I'd calibrated all this bed. Actually, the whole shit came down when I wiggled on this metal beam here. One of these days. Okay, let's keep going. Come on. Come on, you bastard. Yeah. Hey, I tell you, this struggle is real tonight. But I got it. I got it. Okay, so we need to clip this all in here. Yeah, come on, yeah. It is in. Well, we could also put our SPDs in here, right? Into the solar isolator. They would connect to our incoming solar up here and down here to the ground. And this would be only a less than 2 meter run. That would be another option. I just need a bigger box then. Yeah, so I'm keen to hear from you about these SPDs and how to wire them up, and what cable size do we need for the ground and for the positive and negative. I've seen so many different information on the internet. I'm 100% confused now. Okay guys, we've got the west roof finally done here. So we just need to wait for full darkness outside, so we have no voltage on the bus bars anymore, and then we can reconnect the cable up there. Plus I don't have a 63 amp circuit breaker anymore for the incoming cables here. So I will steal a 40 amp out of the electrical cabinet here. That should be enough for the roof. Down there, come up here, do it over here, just do it, don't think about it, do it, just, no, I can leave it, that's fine, perfect, that's cool. And this one goes underneath here, comes up here, cut here. Are you sure, Andy? Are you sure? Cut here. Yeah. Yeah. Cut here. Done. These decisions in life, guys. Amazing. When you have to estimate the length you need to connect it to the terminal. I hate this. Well, as someone recently mentioned on the channel, watch Andy putting a square thing in a round hole. And it fits. That's exactly what we are doing here on the channel, right? Putting square things in round holes. I like this. To do a bit of a trick here. This a bit on an angle. Oh, and it just slides in. Well, we need to take it off later on to put the heat shrink on, right? Super flexible cable, I like it. Okay, so we've got a bit of slack in here, which is good. And also for the positive. Okay, so tomorrow we will measure again and how to cable them. See, I left the space here for the SPD, and now we've got the ground here as well, but this is like 7 meters of cable down to the earth bar, It should be only half a meter. So I don't know how to do that. I've seen switchboards, they had a little bar in here, like a little earth bar, and they measured only from the SPD to this bar, which was only like 5-6 centimeters. But this little earth bar needs to be connected to the main earth bar as well with a cable. So what about this voltage drop then in case of a surge? So I don't quite get the concept of that if you mount your SPD in such a combiner box far away from your main earth point. So I'm really keen to read all your comments about this. Who has done it? How has it been done? And what size earth cable and positive and negative from the SPD to the actual live wires do we need? This is all very mysterious and dodgy potentially, as Paul said. We've connected our 40 amp breaker here for the west roof now, positive and negative going in. This is all in ducting down there. I've managed to get the cable in all the way here at the ceiling. And we have connected our combiner box again with a 16mm cable now, which is good for 90 something amps. And we will have only 50 amps from the solar as a maximum if we have covered the whole roof with solar. So, but this one is mainly about the SPDs. I would be really interested how you have connected your SPDs, if you have them or if you don't care. Here guys, leave all your comments about this down below. I need your help and advice again. That's potentially the thumbnail. And as always guys, thank you so much for watching. Thanks for all your support here on the channel, for all your generous donations. I need to buy beer now. Thanks for all your great support. Thanks for all your comments. And I'll catch you in the next one, coming out here very soon from the Off-Grid Garage in sunny, hot Australia. See, it is still warm. And don't forget to like and subscribe and hit the notification. No, I never say that, really, I never. You either like the video or not, and if you like it, you may subscribe. So welcome to everyone new, and of course welcome back guys to everyone who is here for a while. So it is 8:30 now. I go inside now, edit this video, so people don't complain I haven't posted a video for 2 days. Yeah, I'll do this right now. So thanks for watching again guys. See you then. Bye bye. It is true, people have complained. Well, we haven't seen a video from you in 2 days. Is everything okay? Guys, I cannot make a video every day, really. But yeah, they're coming. More. A few more videos coming.